Hey guys, today we're going to start section 11.4. We will be spending 3 days on this section. Today you'll obviously get the background information. Tomorrow you'll have a worksheet just to kind of practice it a little bit. And then we'll also finish, then the next day we'll finish up actually getting some new notes as well. But all 3 days will be worksheets. They will not be book assignments. Okay, so what we're going to look at today is we're going to look at how do I find the area of regular polygons. Okay, so if you guys remember back, regular polygons are ones that had congruent sides and congruent angles. Okay, so that means all of our sides will have the same measurement, all of our angles will have the same measurements. Okay, we're going to have what's a center of our polygon. We've had centers of circles, we really haven't had centers of polygon, but it's smack dab in the middle, just like you'd expect. It's the same as if you were to draw a circumscribed circle around the outside. Radius of a polygon, a little bit different. We had it again with circles. The radius is going to be the distance from the center, okay, out to any of your 6 vertices. So in this case, this one would have 6 radii because it's a hexagon, which means it has 6 vertices. Okay, and the apothem is the brand new one, is the distance from center to side of the polygon. Okay, and the important thing here is it has to make a right angle. Okay, the apothem will always make a right angle and it will always cut the side in half. Alright, so if we jump into the first example here, it just kind of has you working on the vocab because we have to know how to name things before we can go any further. Okay, the first one they've got is the center. So the center of our hexagon would be R. Radius, you have 6 options, kind of your choice. Okay, I'm just going to go with RK, but you could go RL to M to N to P to J, it wouldn't matter. The apothem, there's only one of these drawn in, that would be from R to S. You'll notice how you have the right angle marking, and it will also end up cutting those into equal pieces, which will be big for us when we move into the next example. Okay, central angle. Okay, the one we want to focus on is the one that's created by the radii. Okay, so in this case, I'm going to use KRL. Okay, that's the one we're going to focus on here because of what we're going to be doing next. Now, the other important thing is not only do you need to be able to identify a central angle, you need to be able to find its measurement. Okay, and to find its measurement, what you're going to do is you're going to take 360 divided by the number of sides. So in this case, it has 6 sides because it's a hexagon, which tells me my central angles would all have 60-degree measurements. Okay, so we're again going to need to be able to do that in the next part as well to help us find the area. Okay, so that's kind of the new vocab that we've got, and then we're going to go ahead and look at these shapes. Okay, so to find the area of a regular polygon, our formula is going to be area equals 1/2 PA. And I do put a capital P there, okay? And the reason I put a capital P there is it stands for the perimeter of the entire shape. Okay, we're going to be drawing triangles inside of these shapes, but when it talks about perimeter, it's talking about the big original shape. It's not talking about the little triangles we're putting on the inside. Okay, the A stands for the apothem. Okay, so the two things you need to always find are perimeter and apothem. Now there kind of is a little bit of a pattern we're going to go through with these, as you'll see here in a second. Now we're going to limit ourselves to only working with 3 shapes. Okay, we're going to be working with hexagons, equilateral triangles, and squares. Okay, you can do it with any regular polygon, but for the sake of simplicity, we're just going to stick with those ones. Okay, so the first shape we're going to work with is a square. Now I know you guys have base times height and that would be fine, but if you look at what you're given on this guy, you're given a radius. Okay, since we're given a radius, we can't use base times height. That's not going to work, okay, right now. So we're going to use the new one, which is our 1/2 PA. Okay, so what we want to do when we're working with these is first thing you want to do is you want to draw in a central angle. So I already have one radius. It doesn't matter if you want to draw the other one up here or down here. It'll work the same way. Since I drew it up here for my notes, I'm going to go ahead and draw it up there for right now as well. Okay, the other thing we always want to draw in is we always want to draw in our apothem because essentially we're going to be working with that right triangle. Okay, but before we can work with the right triangle, we have to figure out its measurements. Okay, this is where the central angle comes into play. Okay, so I would take 360 divided by the number of sides. It's a square, so it has 4 sides. That tells me my central angle is 90 degrees. So this whole angle is 90 degrees, but the apothem cuts it into a 45 and 45. It always splits it in half. So what I end up with down here is I end up with a 45, 45, 90 triangle. Yes, we are going to be using our patterns again. Okay, so the quicker you are with the patterns, the easier this stuff's going to be. Okay, so right now 7 is our hypotenuse. Okay, I want to go backwards to the side, so I would take 7 divided by the square root of 2, and then when you rationalize that, you'll end up with 7 square root of 2 over 2. Okay, and that would be for both of those. Once you have the pieces of your little right triangle, you have everything you need to finish the problem. Okay, that's the big part that you have to find. Okay, so now we can go ahead and use our formula. Okay, so first thing we want to find is perimeter. Remember how I said this cuts it in half. So that is half a side. Okay, so if I take that times 2, I get 7 square root of 2 as a whole side. Now you want perimeter, so there's 4 of those sides, so 4 times 7 square root of 2 gives me 28 square root of 2. And then you need to take it times the apothem, which we already found as well, and that's 7 square root of 2 over 2. Okay, so then it's just a matter of simplifying that, and when you simplify that, you'll get 98 centimeters squared. Okay, so again, it's all going to be about these right triangles. Okay, for every shape, it's just that the angle measurements are going to change. Okay, but we're always going to be working with the right triangles. Okay, the next one we're going to do is a hexagon. Okay, so for this hexagon, they give you the apothem. They tell you it's 4 square root of 3. Okay, so again, you want to finish by drawing in the central angle. Okay, so again, it's 360 divided by 6, which is going to give me 60. So that tells me the whole central angle is 60, which means it gets broken into 30 and 30. So if that's 30, that means this guy has to be 60. So this time we're going to be using a 30, 60, 90 patterns instead. Okay, so then finish off the right triangle. So this is my long side if it's across from my 60. So I want to go to my short side. So I would divide by the square root of 3, which would leave me with 4. And then times that by 2 would give me 8 for the radius. Okay, so once again, you finished your right triangle, you have everything you need. Okay, so it's going to be 1/2 RPA. So I need to find perimeter. So half a side is 4, which means a whole side would be 8. There's 6 of those, so 6 times 8 would give me 48. And the apothem is the 4 square root of 3. Okay, multiply those ones together, and you'll end up with 96 square root of 3. And remember, you guys do not need labels when you're putting things in the Google Forms. Okay, all I need are the numbers and equations. And if I ask for equations, this is what I'm asking for. Okay, that would be the equation, that would be the answer. Okay, we'll do one more here. We'll do the triangle. Again, I know you have a different formula for triangles, but sometimes we're not given that information, as you're going to see here on this one. Okay, so they give us the radius is 18. Okay, so again, finish drawing in your central angle and draw in your apothem. Those are the pieces you always have to have. Okay, so this time it would be 360 divided by 3, which would give us 120. So that means the whole central angle is 120, so I'd end up with 60 and 60. Okay, which means this guy would have to be 30. So you get a 30, 60, 90 again, it's just the angles flip spots. Okay, so you have to be really careful so you don't mix up your long sides and short sides. Okay, so on this one, the hypotenuse is 18. I would divide that by 2 to get my short side. And then I would take my short side times the square root of 3 to get my long side. Okay, again, once you have that, you have everything you need. Okay, so it's going to be 1/2 PA. So 9 square root of 3 is half a side, so a whole side would have to be 18 square root of 3. There's 3 sides, so 18 times 3 would give me 54 square root of 3. My apothem is 9. Okay, multiply those guys together, and you get 243 square root of 3. Okay. The last one is an octagon. We are not going to be doing that one. Whenever you have an octagon, it requires you to use trig, and we're not going to do that. So we're just going to work with these 3 shapes. So they end up being our 45, 45s, 30, 60s, so we get more practice with those. Okay, one last thing. Please make sure you are doing your own work. I have some suspicions that there's a little too much sharing going on out there. Okay, especially when it comes to quizzes and tests. That's really going to come back to bite you when you have to take your ACT in a year or 2. Okay, geometry is really huge on the ACT, especially this right triangle stuff. Okay, so please, I don't care if you help each other on assignments, but please for the quizzes and tests, make sure we're doing our own work and make sure we're leaving everything as exact. Okay, some of you are still rounding things when we should not be rounding. Okay, and I do count those wrong because that was something we talked heavily about before we even went to the e-learning. All right, so please make sure you're doing your own work and it's for your own benefit. I know as it starts to get nicer out, it's harder and harder to be inside doing schoolwork, but we're down to 4 weeks, less than 4 weeks. Okay, so just kind of stay here and we'll get through this together. All right, have a good rest of your day.